Hey guys, Brian Beeler, welcome to the podcast. We've got a good conversation, I hope, we're about to have with Supermicro today. Of course, Supermicro's got designs for quite literally everyone and everything, and so we'll get into some of that, what's going on over there at their shop. And to get us fired up, we've got Michael McNerney from Supermicro. Michael, how you doing?
Very good, Brian. How are you?
Look, we're just trying to stay cool here, so we're filming this in the lower layer of the storage view office in our basement, where it's nice and chilly, which is good.
Yeah. I'm sort of I prefer heat to cold, dark, and wet, but yes, we can. People are complaining about the heat. I'd rather do that than be in the dark and the rain and stuff like that.
Well, we don't have the dark. We have sunshine in the Midwest. How dare you, Californiites, besmirch the Midwest?
Yes, everything's relative, right?
Yeah, I suppose so. So, Michael, for everyone that doesn't know you, tell us a little bit about your role over at Supermicro.
Yeah, so I am here at Supermicro. I've been running a variety of sort of solutions, marketing, and security functions. I'm currently responsible for all marketing and security and network security here at Supermicro.
Well, so you've got two pretty big baskets to work with. Security, we can't go but a couple days without seeing some ransomware something or BitLocker or someone getting attacked by whatever. What is the latest perspective that you guys have on security at a high level?
Yeah, I mean, the high level is really simple, right? It's like, it's super important and it covers every aspect of our business, right? And the devil's in the details, right? If you drill down into how we build our products, how we manufacture our products, how we run our operations, security has to sort of transcend and integrate across those pieces, right? So I think everyone is feeling that same, that same pressure in terms of, driving to higher and higher levels of security, making those investments and sort of, I think, being able to look across those pillars and saying, hey, how do we ensure we're running, sort of best in class, security across our products, our production, and our sort of our own services.
Well, how do you reconcile that? Because obviously, as a hardware equipment manufacturer, you've got security in your own processes, right? As you functionally build these things, you've got security that you must have to audit from component providers to ensure that their practices, as you integrate their chips or pieces or fans or everything, right, is important. You've
Yep.
got distribution security. I mean, that's all the physical bit to get it from raw materials to a product that you deliver to your customer. How much of the security concern in the enterprise is that process versus, did some employee double click on a bad link and now we've got a ransomware breach in the system?
Certainly, the latter seems to be the easier route, right? But you can't dismiss the formers, right? So, tightening those security pieces. It's the traditional multi-layer security approach, right? So we look at security at sort of every level of the enterprise, every intersection to, external parties, internal parties, and just, try to prioritize where those layers are, which are the ones we really want to protect the most, and then put those plans in place, execute, and then as just continuing to improve it, right? The security that was okay in 2021 isn't in 2022, right? We got to continue to evolve that, and we do that across all of our, like I said, our products and infrastructure.
Well, what does that mean? Are there new physical attack vectors that I don't build servers, so I don't know how this works. What does a new attack vector look like on the physical side?
I wouldn't say they're necessarily new. It's just, you're continuing to build the fence higher or the wall
Okay.
higher, right? Every year, people are trying to figure out, how do we do more of these things? How do we get to these, these different pieces? And when there's a will, there's a way, right? So there's all these pieces just have to continually be improved.
Yeah, it's interesting. We had a guy from Eaton on a couple weeks ago, did a podcast, and he was talking specifically about some of the not quite legacy systems, but older control boards that are on devices like UPSs and PDUs in the data center, how they can be an at-risk element, that it's not necessarily Yeah, if you're rolling in a brand new server today, like you say, you're going to have the latest and greatest of whatever you can provide from a security standpoint. But a lot of this IT infrastructure sticks around for a long, long time in the data center and can be a higher risk entry point for someone that does get access to the network to kind of sniff around and see what's out there communicating. I mean, I suppose I don't really have a question there for you, but
No,
you,
it's the classic weakest link, right? It's
yeah.
the problem is the weakest link, right? It's not, oh, I got this new service, I've built it super secure. It's the old print server that's sitting there that, we'll update that someday. Those are the kinds of issues you got to watch out for.
That's why you need the guys from Office Space to go take a baseball bat and to beat the snot out of your photocopier every now and then just to modernize the equipment.
Exactly.
So speaking of modernizing equipment, I mean, you guys are a perpetual announcement machine, adopting accelerators, processors, flash drives, whatever is coming out over time. And I know you guys did a lot at Computex. You were showing off the ruler servers there and showing some of the modularity of your GPU servers.
Yep.
With CPU refreshes likely this fall, what are you excited about? What gets you guys jazzed up from a hardware perspective these days?
Yeah, I think the sort of excitement in the hardware space is just the sort of continued fundamental improvements in the hardware, driving kind of entirely new levels of service, right? So uh, when you look at every angle of performance in the hardware space, they're all going up and to the right, right? It's like everything is improving dramatically. Everything is moving really fast. The addition of, with more competition in the market, right, we see, you're going to see more pressure to get product out to market from a lot of the vendors. So, we're continuing to sort of stay on top of that, in delivering those new products out to market. And, for the customers who can take advantage of it, it's clearly sort of competitive advantage, right? So, if I can do these things with more efficient storage, more efficient, power costs, all of those pieces, your enterprise is going to be more successful. And so we see there's a lot of opportunity right now in sort of that hardware innovation. Everything is just continuing to, double Moore's law. All these things are just continuing to drive out into the market space. And as a vendor, I think our big role for our customers is, trying to arbitrate some of that stuff, trying to identify, well, what should I be using for this kind of workload? How do I get all these different options from all these different vendors? Please try to rationalize them for us, right? And so that seems to be, more and more of a role we're playing with our customers, is that sort of trusted advisor role of, okay, there's a lot of, IPUs, DPUs, CPUs, GPUs, all the different letters of the alphabet, what's really sort of ready for prime time.
I do not envy the task because you just listed some of the alphabet soup, but we're in the midst of, within a few months, talking about things like CXL. We're talking about PCIe 5 and what that means for storage, for SSDs, for all the new capabilities there. And all, by the way, we don't have infinite lanes, so where do we put them? And does Gen 5 go to the front, back, all the places? And if so, like, what are all those implications? We've got form factors and SSDs. I mean, you guys have been playing in E1S, E1L, and what Intel called ruler before then for years. But we've got E3S this time, which looks like another potential form factor. And then all the other challenges around connectivity. Ethernet, fiber is still a serious conversation. You mentioned DPUs, so how do we take advantage of something like Bluefield or some of these bespoke DPUs that are available out there? I mean, your teams must be either crazy or almost there in trying to suss through all of this, right?
Yeah, no, it's definitely, like I said, it's a good time in hardware, right? So it's not, sort of a single monotonous, okay, we're going to put a new product out every 2 years. There's just so much innovation happening, and I think there's a lot of sort of breakaway opportunity for customers who can identify, the right technology for their business, right? So how is this going to move forward? We're excited to see the ES stuff come out. Getting a form factor that's optimized for SSD just makes a ton of sense, right? It's like, why are we in 2.5 inch? Well, that's what the spinning drive is like.
Mm-hmm.
It's like, well, so seeing those things come out and some of the efficiencies we can build into those form factors in terms of airflow, et cetera, are really going to help the systems designs move forward. So we think it's sort of an exciting time in hardware. I mean, people talk about, I think this idea of a sort of white box server or whatever is kind of long since past, right? You don't get a sort of a general server. I'm just going to use this general purpose server. It's going to do everything. There's so much optimization available that that the successful customers are sort of building out their infrastructure, specifically for their workload and able to achieve, cost, performance, efficiency, based on that sort of top-down design.
Yeah, well, I mean, for guys like you that have had a history of making sort of designs that encompass all of these technologies so that your customers can be wherever they want to be on that spectrum, I suppose you guys might even have to do some editing and portfolio, right? This time around to kind of lock in on a few concepts. I don't know. I mean, that must be a perpetual challenge, but with so many choices right now, it feels a bit crazy to architect a system for all of them, right? It can't be done.
Yeah, I mean, I think we continue to focus on commonality, right? So we call building blocks essentially. It's like, how can we build the subsystems that then we can sort of build up into larger systems and make those subsystems reusable across multiple architectures, across multiple designs. And so though we might have hundreds of different offerings, we're building that off of a core set of building blocks that we're able to reuse, test, validate, and sort of leverage. So the more designs we do, the sort of better the building blocks get, and so the whole systems, all the systems sort of improve over time. It's a little bit different way of doing it. And like you said, I think in this environment, it's played out pretty well for us because we're used to building a lot of product, and now that there's all these options out there, that sort of plays to our strength.
Yeah, it's funny. So we saw the universal GPU server you guys launched back at Supercompute last year, I think, in St. Louis, or at least that was the first time I saw it hands-on. Vic gave us a tour of it, but even then we couldn't quite pry it open and see the inside bits. I understand it was early. At Computex, though, you guys were showing that server off again, and really interesting because we clipped out a little bit of the video where the socketed NVIDIA board gets lifted out, and then conceivably you could put in something else there. I mean, that's not exactly the modularity you were talking about, because I think you're talking about mostly your components, but that kind of stuff, and even I guess even that main board, you could have Intel or pull that out and drop an AMD in there without, I mean, you wouldn't do that in the field, but it does give you that platform then where it's a lot easier maybe to switch out those components, right?
Yeah, I think so. I mean, yeah, I think when we talk about building blocks, a lot of times we're talking about our own components, but it really does sort of play out up the stack. And so the big lesson for us right now, and this is what we did some of this work with IDC, was customers are looking at, I've got a specific workload. How do I build an infrastructure that supports that specific workload, right? And how do I optimize it? And how do I use a different CPU? Do I do a different GPU? Do I need more memory, less memory? How do I get that system and that system design that sort of is best serving my workload? I look at it as sort of the custom suit metaphor, right? So you think about an off-the-rack suit versus a custom suit, and what custom suits are expensive. In the case with Intel, which we did with this white paper, was Intel's buying 350,000 custom suits. So all of a sudden, that custom suit becomes very sort of optimized for their workload, very specific what they do. And the idea that it's expensive to buy a custom suit when you're running at scale, it's actually, it's inefficient to not have the custom suit, right? To not have the optimized infrastructure and not to be using some sort of average offering, some sort of, well, this should work for your workload, pretty much, but not be sort of tailor-made for it.
Well, you talked about some applications dictating hardware decisions, and I think that's sort of a classical way of looking at infrastructure. But we've looked at these things in the past, and enterprise IT, as you well know, goes through these cycles, not even hype cycles, they're legit cycles. Like 5 years ago, hyperconverged infrastructure was going to take all of our applications and throw them together, which it did effectively for many applications, but not all. But we still have some tier 0 business critical databases or transactional something or other, but that needs to be on some other kind of hardware. And then we've got this AI or HPC initiative, and that needs to be on another set of hardware because the other two hardwares we had aren't GPU ready, and high speed networking and everything else we need. Just listening to you talk a little bit, it makes me feel like we're that conglomeration of everything coming together that we were talking a lot about 5 years ago, maybe, whether it's on-prem or in the cloud, may be starting to be outgrown as necessarily the right answer for most enterprises.
Yeah, I think, like I said, I think for us, where we're seeing value, where our customers are seeing value, is in that optimizing infrastructure. So, we look at this case with Intel, where the Intel IT department, 98% of their infrastructure is focused on chip design, right? Running workloads, working on chip design. 2% of it is running standard, 2 to 3% is running their standard IT operational pieces, right? And so being able to really optimize that set of workloads for, not just at the hardware level, but the entire stack, all the way up through, management software, through application software, libraries, infrastructure, all those pieces sort of come in, to build out that architecture. And I think the big overarching trend is just this move towards software defined, right? So, software defined everything is really coming into place. I mean, you see it in your core storage market, right? Where before everything was based on, proprietary boxes with proprietary software, and we would update these boxes when we were sort of, we had to rebuild the entire stack. And now the software defined storage market is, you're seeing these companies come out and define, storage architectures and storage applications that really can sort of take advantage of these different hardware capabilities, be it the, E3S stuff, be it a lot of the DPU architectures, all these pieces. Think about how long that would take to reach market in sort of the traditional storage market. And now there's probably, 10 startups working on, something to do with the DPU stuff, and probably more, frankly. And so I think that's really the overarching model, is this whole software defined marketplace, open source, software defined architectures running on, sort of optimized hardware, is really where we're seeing just a ton of value get created.
So you guys, being in the hardware business, you see where all the hardware is going, which is an interesting level of visibility. Obviously, cloud continues to be a massive investment area for you and your competitors that provide systems and such for the cloud providers. What are you seeing in terms of traditional channel sales to the enterprise, et cetera, versus cloud investment? Because I think you would have an interesting perspective there in terms of where the workloads are going.
Yeah, I think that, what we're seeing essentially is like everything is transitioned to a cloud architecture. And, everything is transitioned to this open source architecture, or this sort of software defined architecture. And so we see people running internal IT environments. We see, big cloud providers providing, cloud infrastructure, that everything is sort of getting architected around sort of a common, scale out, highly reliable, highly efficient architecture. And, what is a cloud architecture versus a non-cloud architecture? I don't necessarily think that's a super productive conversation, but I think in the way we see this is like everyone's building out, cloud architectures, even within their own data centers. And, is that sort of IT as a service? How does that look? really sort of depends. But we were this white paper we did. They're talking to the guys at Twitter, right? And they're building out, cloud. They're building out their service, based on sort of these on-prem cloud architectures, and how do they build that out? And so, is that a cloud? I think so. So I think we've just seen this sort of generalization of cloud across, the majority of IT workloads, and anyone sort of building stuff on a modern architecture is kind of building it on a cloud. Is there still some legacy? We talked about it earlier. Legacy tends to stay around a long time, but anything new being built is largely being built around these cloud architectures, and I think sort of falls into that category.
Well, yeah, we typically think about cloud as Azure, GCP, AWS, the public clouds, where their business model is to perhaps support their own initiatives, but then to make money off of reselling these services to the market, right? But I think you bring up an interesting point, because when we look at the big software as a service guys specifically, but more than that, I mean, Twitter, Salesforce, other big software companies that are building clouds just for their own internal consumption. It sounds like that's a model that you're seeing more of. Is that driving all the way down into the enterprise and smaller orgs, or kind of where is that oil water line where perhaps it's too much of an endeavor for a business to participate in?
Yeah, no, absolutely. I think that is the sort of trend we see, right? I think one of the things I think we sort of look at is, when you look at the big three cloud providers, there is sort of this momentum like, oh, everything's moving to public cloud. It's just a matter of time until everyone's going to move their workloads to public cloud. But then we go out to our customers and we hear sort of a completely different message, right? And some of the IDC numbers here that we published were pretty interesting, right? So they're still seeing, over half the IT budgets are going to be on-prem, for the foreseeable future. I think they said 5 years. 70% of the people they talked to, was a couple thousand people, they were moving stuff off public cloud back to on-prem infrastructures, right? And so I think this idea of, cloud is public cloud, I think is a little bit is a little bit too specific, right? I think cloud is an architecture, based on, like we said, open source, Linux. They've just done tremendous things there in the past, that any enterprise can take advantage of, right? And does it make sense to go out and use a public cloud? Sort of workload dependent. We see a lot of people doing like early dev in public cloud, and then it comes to deploy at scale. I can do that more efficiently in-house than I could, in a public cloud architecture. And where's the line between, does it make sense for me to sort of outsource my infrastructure? I sort of point back to the Intel example, right, where 3% of their IT infrastructure is standard sort of workloads, ERP, et cetera. 97% is the core of their business, right? So it's like, at what point does it make sense to run the core of your business, outside of your business? I think that's it sort of depends on what kind of timeline you're thinking of, but for most enterprises, I think you want to own your business.
Well, talk about that a little bit more, because I think one of the reasons, well, people went to the cloud initially because it was easy. It was friction-free largely, or at least prospectively, and they could meter cost on OpEx instead of CapEx. So whatever financing models are in vogue at the time helped dictate some of those decisions, right?
Yep.
But the cloud is also really good for certain things, like going out and snagging a GPU for a little while, because that may not be in your organization as easy as it sounds, right? To go stand up something that has a couple A100s or whatever in it. I mean, that's a substantial investment. If I'm going to bring that on-prem and toy around with it, to learn, to figure out how AI can be productive for my business versus, and maybe that's what you're saying, is go to the cloud, learn, get access to the equipment that you need, but when you're ready to take this to market, then maybe that's the right time to make some sort of substantial investment in your own infrastructure.
I think that's one of the examples you see out there, is people doing dev, doing some dev, do some test on the cloud, we see sort of capacity on demand issues, right? Hey, I'm going to have a peak, and I want to move. I want the ability to sort of meet those peaks with on-demand cloud architectures. So there's a real convenience factor there of public cloud, and we definitely see that. I think the market sees that. It's just sort of at what cost. One of my favorite AI stories is I ran into a startup doing AI work, and they were trying to get some servers from us and trying to hit me up for some servers. And I'm like, well, why don't you just, and they're like, no, we're deploying, the plan is to deploy on public clouds. I go, well, why aren't you dev on public cloud? He's like, well, it's like super expensive. It's like, I can buy one server
Just
from
wait till
you
your
or
app
two
gets
servers
running
from
up there.
you, and I can throw all my dev at it. And, we can run workloads overnight. And every time we do a new run of the model, it doesn't cost us money. It just costs us, it's just the server sitting there. And so it's sort of this interesting, sort of ironic moment where I'm like, that's interesting. I'm developing for the public cloud that I'm going to do all the dev in house. I thought that was kind of ironic, but yeah. So I think that's certainly there's a convenience factor there. People are seeing on the public cloud space that, and I think we as an industry need to do better there, right? We've the complexity it takes to roll out some of these architectures and infrastructures, right? I can go to Amazon, I can put my credit card in, I can get a fully functional stack. I want to do that myself. It's like, okay, where do I even start? Where do I go? How do I get there? We still see people sort of, coloing things, obviously, for efficiency, and I still control my infrastructure, but I don't necessarily have have my own data center. There's a sort of shades of gray here, but we see those sort of deployments as sort of having different benefits for different times in the life cycle.
So, the other thing is we look at some of these popular workloads like AI. So you might do your training in the data center or in the cloud, but then your inferencing may oftentimes, retail is a great example, resource exploration. There's all sorts of others where you would push that out to the edge.
Yep.
What are you guys seeing? This is such a popular theme right now, but what are you seeing at the edge in terms of how these infrastructures are being deployed, what that looks like, and I guess even to define the edge further, because you guys touch so much of it, the industrial edge, 5G, whatever. I'm talking about high value sort of configurations in retail that's doing AI kind of workload.
So I think the really, the move towards and I don't want to sound like a bureaucrat. The move towards software defined in the edge is really exciting, right? If you look at traditional telco infrastructure for 5G, that was all built out by these large telco OEMs. They built the software, they built the hardware, and now when you see things like Open RAN, Open Radio Networks, all these pieces are sort of moving to this. So you're getting this whole generation of edge systems that look a lot like a cloud architecture, and really unleashing innovation. And so we're able to bring a lot more power into that. We're dropping GPUs into the edge, so we don't have to move data. We can improve latency and deliver some more quasi real-time services. Though the autonomous driving guys will tell you what it takes to really do autonomous or really do real time in that space. But I think there's some really interesting applications that are sort of enabled through bringing that data center class hardware out to the edge and making it maintainable, making it serviceable, and and leveraging sort of the economics of that sort of x86 architecture.
Well, you talked about security, which is early on, which is important at the edge, but the serviceability is another one that you just mentioned there, that you may not have IT people on site, or you might have data scientists on site that become pseudo IT people, or no one at all, and you have to be able to withstand some degree of failure until somebody can get out there and do the repair. I mean, as you think about what goes into that from an engineering standpoint, and we've got some of your edge stuff right now. We've got one of your 2U3 node guys, real dense little box. What do you have to do, or what's different for the edge when you guys think about what you have to do there from a reliability standpoint?
The serviceability really comes into that sort of like building out. I mean, that's what when you think about the telco OEMs, central office infrastructures, I mean, they sort of define serviceability and reliability, right? It was like, I think they used to design them so those things could catch on fire and still operate, right? So it's like, there's a level there. A lot of that is built up into the software layers, right? So we said, hey, how do we architect this from a software layer where we move, modules in? You talk about sort of a multi-node system. That's a classic sort of reliability play, both, in the HCI space where I've got, backup, as well as out on the edge where I can have redundant servers out there. It's a hard problem to solve, but I think people have gotten really smart at this at the software layer in terms of, zero shared data, all of these pieces that they're being built into the shared networking architectures that are getting built out in these environments. But I don't know if there's necessarily an easy way to do it. I just think I think as we look at the sort of the quality of the, sort of the traditional x86 ecosystem, right, just based on the volumes, right, driving, higher and higher quality for, memory, CPU, all these architectures, I think improves things, but I don't know if there's any silver bullet here in terms of, we're going to get so much better quality and resiliency. I just think people recognize it as, everyone's using these systems all the time. Nothing can sort of have a maintenance cycle anymore.
Well, I mean, a big part of it's got to be thermals, right? Because these systems, I mean, your 5G systems that go hang off of a pole. Talk about low maintenance. There's not a guy climbing the pole every day to make sure that the box is nice and cool, and oftentimes it's very much not.
Yeah.
In retail, these things are going in a back office oftentimes where maybe physical security is a bigger concern than anything else. They've got to be kind of locked away and maybe in an office that's not extra air conditioned, conducive for these environments, or they're dusty or whatever. So I mean, the physical challenges I think that probably assault your boxes at the edge may be worse than anything.
Yeah, I think the interesting things there is we do a lot of work on data center efficiency and trying to help people build more efficient data centers. It's kind of one of our beyond our financial goals, like the idea is like how do we sort of make sure what we're doing doesn't necessarily kill the planet. And one of our first things we say to a lot of data centers customers we talk with is like, what are you running your inlet temperatures at? And you can turn that up from 10 to 20 degrees. Like, what do you mean?
They're running too cold, right?
They're running too cold. I mean, and back in the day, right, and I don't want to date myself, but, back in the day, keeping the IT infrastructure running was a real, was a very sensitive, a very sort of like, sensitive environment. And, these systems over time have just become, much more robust. So when we look at the performance, we have long-term performance data in terms of, systems running at higher temperatures, and we're just not seeing lower reliability on it, right? And so, I've always kept my data center at 68 degrees, and it's like, well, why? Why did you do that? And the answers are typically, well, we've always done it that way. And so, trying to move some of those, pieces. Yeah, I think you come back to the edge with these very specific, you need fanless, dustless, environments and systems built to these things. I think what really gets interesting there, and we're out at Embedded World this week, showing off some of the new systems, is what you can get into that fanless, dustless environment is a multi-core processor with quite a bit of memory on it, and so. It turns into an application platform where traditionally, at the edge, you could have very little compute power. And just like you see in the data center, those edge boxes are getting, tremendous amount of capabilities, almost for free, right? Because it's like, listen, we're building these new processors and they're going faster. We're building this memory. It's getting bigger, cheaper, higher performance. And so that entire edge box, which used to be, well, hey, I got to make this thing to fit into this space. It's got to have all these thermal characteristics. It's got to have this. And you're like, okay, well, I can still give you, 8 cores and, and memory to write real code in, has really sort of helped there.
Well, you talk about some of the advancements in technologies, and we talked early on about Gen 5 and CXL and all this other stuff coming from NVIDIA, AMD, all these guys. A lot of great stuff. Every single one of those things I just mentioned adds heat to these systems, and so that's a big challenge. We've talked a lot lately about liquid cooling. I know you guys have had loops in your blade systems. I know you've done it in some of your others as well. What's the latest perspective from Supermicro on liquid cooling? What does that look like? Is that HPC still too early for enterprise? Like, what are you seeing from what you guys are selling?
I think at the end of the day, as we look longer term, the liquid is just a more effective way to cool than air, right? So, at the end, what's the more efficient system? And I'm always a fan that the industry always drives towards the efficiency, right? So they're always going to reach that point where, and I don't have the numbers in front of me, but I mean, I think we're talking about, the ability of liquid to sort of dissipate heat versus air is like, the numbers are crazy, hundreds of times higher, et cetera. And so at some point, personally, I'm like the end game seems like, hey, things are going to go liquid. And then as you mentioned, as we add more circuitry into the memory, into the CPUs, into the GPUs, that's all driving higher and higher temperatures, right? Higher TDPs, higher TKs, all of these pieces are sort of coming into play, and you bring liquid into that equation, and it solves, sort of a lot of issues of moving air around and doing some stuff. There certainly is challenges, I think, with the sort of average data center to be, you're bringing liquid into my data center, like, what are you talking about, right? So I don't think there's a we'll see it roll out over time. But for the larger clusters, for the larger data centers, you're going to see, liquid get adopted, more and more as we move forward. And especially as these, like you said, the new technologies come out, which are going to require more power, which again, generate more heat. And, liquid's a good way to sort of get rid of these things, and just the efficiency of it. And, ultimately, I think as we look at the crack systems to cool everything, I think there's some interesting reliability arguments to make around liquid, where most people are seeing as liquid as potentially a liability. Just, being able to contain that heat in a simpler system, with less components and less infrastructure, is ultimately going to be more reliable and more cost efficient.
Yeah, I mean, less electricity consumed, right, per device. And the key, I think, too, is this has been successful in HPC environments that are often at universities that have a big green initiative, that have sometimes a footprint issue. So, liquid can help there as well, but also have the wherewithal to take that heat and do something else with it, right? To recapture that energy and, heat a pool or whatever the other popular ideas are.
No, we've got some customers out there in the Netherlands, like, heating the city
Yeah,
with
right.
their data centers, right? And it's pretty cool to see, what you can do with excess heat. And especially, I mean, I don't know the physics of it that well, but I think this, when it's in a liquid form, it's a little bit easier to contain and control and then reuse.
Yeah, maybe so. So that's interesting.
I think it's steam engine, right? some sort of basic concept, or hey, I can move water around as it is for higher temperature, and there's some interesting things there.
Right. So I think most people think about you guys as a hardware vendor, and we've spent a lot of time talking about that. But you did drop in some software nuggets and concepts along the way too. I know I've worked with Ocampo and your team and some others around what you guys are doing with Super Cloud Composer, which is pretty cool. Also some of your open designs where you're putting together reference architectures, but also working with customers to install software to make those things come to life. What is the latest true vision for Supermicro in terms of, obviously everyone knows you for hardware, but how much of the company is a software company at this point?
Yeah, it's depending on which engineers you talk to around here, right? So, yes, I mean, I think Supermicro is considered sort of a hardware vendor, but when you look at all the software that it takes to run that hardware, it's BIOS, it's BMC, it's management tools that run on top of that. So, we've literally tripled our software staff over the last 2 years, just uh, just because of all of those requirements, right? And a lot of that manageability piece, reliability. We talked about the security stuff. Security doesn't fix itself by itself, right? So, bringing in that sort of whole function across the organization. So yeah, so I don't think that. I think when you look at today's modern hardware, there's a huge sort of infrastructure software that actually runs, operates, and maintains those pieces. As we look to fix things, we typically fix them. We run into bugs, we fix it in BIOS, right? We fix it in BMC, versus coming in and trying to relay out boards. So there's a tremendous software investment. It's a little bit hidden from the typical market, right? You start a server up, you say, okay, great, and there's some screens that maybe pop up at the beginning, but there's a lot of software, a lot of computers within the computer, operating and running to deliver that.
So I brought up your GPU server, which is one of the things we think is pretty cool that you guys are doing. You obviously have many different x86 systems. Is there something else that you guys are working on, or that you want people to know about that maybe they don't know that Supermicro is working on, or perhaps a system that you love that maybe doesn't get the attention it deserves? Leave us with
Yeah.
a piece of hardware that people should be checking out when they go hit your website.
Yeah, no, I think the GPU portfolio stuff is really compelling right now, right? It's a classic sort of workload optimized market. You talked about training, you talked about inferencing. If we're talking about we're talking about different ways of digital twins or rendering or online gaming, all of these pieces. There's not sort of a one size fits all, and so we've really spent a lot of time going out and building that portfolio of GPU systems that really matches those different workloads. And it's kind of fun to see, if you just go look at the GPU product page, like, okay, hang on, there's all these different GPU systems. What am I actually doing? Why is there so many options? And as you get into it, you realize, well, because there's different workloads, and those workloads do things. And it's really easy to see in the GPU space just because it's very specific hardware. Are you running? How many GPUs you're running in a box? What are you trying to do with them, et cetera. So I think I think that to me is really sort of the fun space. Is just go out there and try to understand the GPU portfolio. I know that maybe isn't the best thing for the marketing guy to say, but it's just that it's just there's a lot of stuff there, and it might make people think about, well, what can I actually do with that optimized hardware?
Well, I think as the marketing guy, here's your challenge for GPUs, right? Is to take all the offerings from NVIDIA, Intel, AMD, and whoever else is coming around the corner, and you got to get them all in a decision tree, like a choose your own adventure, because
Yeah.
here's a dozen or more offerings from these guys, and what is the workload? Because it very much matters too. It's not just the box that you put them in. It's each one of these cards is just a little bit different. At the edge, a T4 versus an A2. Just because A2 is the newest doesn't mean it's the best for all of these workloads. And it is a absolute bear to sort through, an A30 or an A40 or whatever. It's just so complicated to understand that. And then again, it may not matter because you just get down to what's available in the channel to purchase, and you may have limited choice. But man, if somebody could come up with that decision matrix across all these enterprise GPUs, I think that would be something.
No, and to me, I mean, I'm sort of a geek at this front, but actually, it's the opportunity, right?
Okay.
Whatever you want to say, 18, 24 months ago, there was only one choice. It was
Yeah.
like easy. Hey, I'm going to deploy that for this. I'm going to deploy this for that. And now there's all this variety. Needless to say, that's going to have an impact on cost, right? As long as, cost competitiveness drives cost. So there's a lot of really interesting things to do. So I know the frustration is, oh, just give me the easy answer, right? Can I just have a single vendor who delivers everything for me? But I think you're in sort of this a little bit of a golden age right now on the hardware front, where there's just so many options to take advantage of. Those decisions can make really big impacts on the business.
Well, not that you guys were ever not selling hardware, but this move of companies building their own clouds and more organizations engaging in on-prem and edge infrastructure. I mean, the market's coming to you, so this is a great time, especially as we're upon this threshold of a massive refresh in CPUs and all the enablement that they bring. I mean, it's a great time to be there. So we're looking forward to seeing what you guys come out with next, and can't wait to see the rest of the portfolio as it emerges later this year.
Yeah, it'll be an exciting time.
All right. Well, thanks for joining us on the pod. We appreciate it, Michael.
Thanks, Brian.